In this section, I will teach you how to use the graph of a function to sketch the graph of its derivative. So notice that in the example right here, I have the graph of the function only. I don't even know what the function is, okay? I have the graph only. So using the graph of f, can you sketch the graph of f prime? This is not easy to do. You have to think about the tangent line. So let's take a look at this function. So we have a function that looks like a W, right? So when you think about this, you have to think about something like playing a roller coaster. So starting right here, you are going downhill, right? Playing a roller coaster. So you are keep going down, okay? Going down, going down, going down, and then eventually you reach to the bottom of a mountain. So eventually you can take a break right here. So at this point, the slope is equals to 0. And then you start go up, go up, go up, and then eventually you reach to the top of a mountain. The slope is equals to 0. And then you go down again, and then you reach to the bottom of the hill. That is equals to 0. The slope is equals to 0. And then you go back up again, and then keep going up. Alright, so before we sketch the graph of f prime, I'm not going to do anything in here at this point. Let's take a look at this xy axis. So this one we have x, but the y axis we have a f prime of x. I want to analyze this. X and f prime of x. You have never worked in a graph like this in the past. So let's take a look at this. So in this graph, I want to break it down into 3 pieces. So let me use a highlighter to highlight the x-axis right here. Okay, x-axis. So we have 3 pieces. One above the x-axis. One is exactly on the x-axis. And then one is below the x-axis. Now, tell me what happened when we have a graph above the x-axis. When we draw anything, any graph above the x-axis. So let's put it down right here. So above the x-axis, what do we have? We have the y value, f prime of x is greater than 0. So we have a slope greater than 0. Slope greater than 0 means the slope is increasing. I mean the graph of the function is increasing and is going uphill. Alright, so we have a positive slope. The slope is going uphill. What if I have a point exactly on the x-axis? So on the x-axis, what do we have? We have f prime of x is equals to 0. So that means we have a 0 slope. What is 0 slope? 0 slope means if you look at the tangent line is horizontal. Horizontal tangent line. So that is the midsection of the graph. And then what about below the x-axis, the bottom, the top, the middle, and the bottom? The bottom is below the x-axis. So below the x-axis, so that means f prime is less than 0. The graph of f is decreasing and going downhill. And notice I put a few numbers, I put a few marks on the y-axis, the f prime. So let's take a look at the 10. F prime is equals to 10. What does that mean? The slope is equals to 10. That means if you look at the tangent line, think about the slope of a tangent line, slope is equals to 10. That means the slope is going uphill fast and the slope is pretty steep, right? So as we are getting closer and closer to the x-axis, we have f prime equals to 2. The slope is still going up, but it's slower, right? It's less steeper compared to slope equals to 10. Just take 2 pictures in your mind. Slope equals to 10. You are driving. Slope equals to 10. That means you have to press the gas pedal really, really hard to go uphill. Slope equals to 2. You are still going uphill, but you don't need to press the gas so hard, right? And then slope equals to 0.5. You are still going uphill. You are not taking a lot of energy because it's less steeper compared to slope equals to 2 and slope equals to 10. When the slope is equals to 0, you are driving on a horizontal line, just like walking. You don't need a lot of energy, right? What about below the x-axis? Slope equals to negative 0.5. You are start going downhill, so you don't need to press the gas pedal. You just let the brake go, the car will just roll forward. And then when the slope is equals to negative 5, what are you trying to experience? When the slope is equals to negative 5, what do you experience? The road is pretty steep, it's going downhill. So if you just let off the brake, the car will just roll forward really fast because the slope is pretty steep. What about slope equals to negative 10? When the slope is equals to negative 10, well, I don't suggest you to let the brake go. I suggest you to like step on the brake. Otherwise, you will crash, right? Because slope equals to negative 10, the slope is pretty steep. It's going downhill, right? Just like playing a water slide. When the slope is negative 10, like you are trying to free fall, right? Negative 10. She's going down. You have to press the brake. You have to press the brake so up to avoid crashing your car. So let's go back to this picture. So in this picture, I have the function f of x, and then I want to sketch the graph of f prime. The way I do this is I want to break this down into pieces. So let me do this in a different color. So what I really want to do is at this point, the top of the hill and the bottom of a hill, here is how I'm going to break it down. I'm going to use this A, B, and C. All right, because at A, the slope is equals to 0. At B, the slope is equals to 0. At C, the slope is equals to 0. Again, remember, on top of a hill, the bottom of a hill, the slope is equals to 0. Be careful. That point can never be a sharp point because the slope is undefined at a sharp point. So why do we have to do this? Because here is how I look at the graph. When x is less than a, tell me what the slope is. When x is less than a, we are playing roller coaster. The roller coaster is going downhill when x is less than a. So just like this, right? So we have a tangent line, and then we have a tangent line. Take a look at these three tangent lines. We are going downhill, but we start going downhill really fast. But as we getting closer and closer to A, we are trying to slow down because this tangent line is less steeper compared to this tangent line. So when x is less than a, we are going downhill. F prime is less than 0. When we reach to a, as x equals to a, we just reached the bottom of a mountain. We have a horizontal tangent line, and then the slope is equals to 0. So now let's sketch the graph of f prime. Just look at these two clues. When x is less than a, we start with decreasing, going downhill, but going downhill really fast. So that means we should have a curve that is way below the x-axis. As we are getting closer and closer to a, we have to approach to slope equals to 0. So this point, when x is equals to a, we have a slope equals to 0 because at that point, f prime of x is equals to 0. But what about when x is less than a? When x is less than a, the slope is decreasing, right? Decreasing means we have to draw something below the x-axis. And this is how I do it. We have to go like this. So if you take a point right here, so that is x less than a, x less than a. The slope is going downhill pretty steep. That's why we have some curve that is way below the x-axis. But as x is getting closer and closer to a, we have to reach to 0. That means there is no other way to go. You have to draw a graph that connects to point A. And then what about x is between A and B? So let's go back up. X is between A and B. What do you see? Here is what we see. Again, roller coaster. We start going to the top of a hill, so roller coaster, and then eventually we reach to the top of the hill. So now you are at the bottom of the hill. So to go uphill, you have to, gear up and work hard to go uphill, right? So you need a lot of energy just like driving, you have to press the gas so hard to go uphill. So we start with a lot of energy, we have to go uphill, and then eventually you reach to zero. So you need to start walking really hard, and then eventually you reach to zero. How do we draw that? First, we have to go uphill. So A to B, we must have to do something right here. So we have to go uphill. Okay, so I'm just continue my f prime, but eventually we have to reach to slope equals to zero. So you have to join this point. The only way to go there is you go up. You are still going uphill, but eventually the intensity of going uphill is getting slower and slower. So eventually we will go like this. All right, so how come there is a curve? We are going uphill. The entire piece, this little parabola, the entire piece is above the x-axis. That means between A and B, the slope is absolutely positive. But as soon as you reach to B, you will get to a slope equals to zero. So you already go up, right? In order to reach to B, you must go up and then go back down to join that point at B. Okay, and then what about between B and C? So X is between B and C. So let's fill up this A and B. What do we see? The slope is going up. F prime is greater than zero. Between B and C, the slope is going down. F prime must be less than zero. So between B and C, your curve of F prime of X must be below the x-axis. All right. So below the x-axis, we start with decreasing, and then eventually we reach to zero. So that means we have to go decreasing, and then we have to join this point. So the only way to do so is you make a turn right here. That's the only way to do it. Because when x equals to c, we have a horizontal tangent line, the slope is equals to zero. And then what about when x past c? When x is greater than c, okay, we start going up. So we just go up. As x goes away from c, the slope is going so steep, right? So as x goes away from c, the slope is increasing. So that is the graph of f prime. Let's take a look at the next one. So the next one we have f of x. I want you to sketch f prime of x. Okay, how do we break this down? So first, I would like to break it right here. So this will be my A, this will be my B, because on top of the mountain, we have a horizontal tangent line, and then that's it. So this one, I assume that this piece is as x goes to infinity, y goes to infinity. All right, what happened when x is less than a? When x is less than a, let's take a look at the tangent line. So the tangent line is going up, right? So basically, from A to B, the tangent line, they are all going up. It looks like in this roller coaster, they are trying to go up and then eventually reach to the top of the mountain. So when x equals to a, going up, f prime is greater than zero. X is equals to a is still going up, f prime is greater than zero. And then once you reach to b, when x is equals to b, you have a horizontal tangent line, f prime is equals to zero. So we start with going up. Look at these two going up. Going up means look to the f prime. So this is a, this is b. We must have a curve and we must draw something above the x-axis, because above the axis means f is going up. The slope is positive. But eventually, we have to reach to this. I have to join this point. Between A and B, the curve must be above the x-axis. So let's take a look at the slope. It looks like this. At this point, they spend a lot of energy to go up, right? As x is getting closer and closer to b, we are trying to reach to a zero. So it looks like we have this very steep, but eventually we reach to a zero. So we have something very steep, looks like this. And then eventually we reach to zero. So the slope start with very steep, going up, and then eventually we reach to 0. And then what about greater than b? When x is greater than b, the slope, they are all decreasing. That means f prime must be less than 0. These are all decreasing. Okay, but eventually we reach to this. Looks like eventually we will reach to a straight line. Okay, how do we do this? It looks like the roller coaster drops pretty quickly, and then we reach to a horizontal line. So drops quickly, and then we reach to a horizontal line like this. How do we do it? They must be all negative, but eventually we reach to 0. So all negative means you have to draw a piece below the x-axis. So all negative, but then eventually as x approaches to infinity, so as x approaches to infinity, the slope approaches to 0. So eventually you will just have to start touching the 0. So that will be the graph of f prime. All right, moving on to the next picture. So the next picture, we have a semicircle. So semicircle, I will do this. This is A, this is B, because on top of a B, I have a horizontal tangent line, and then this is a C. So between A and B, it looks like it's going up. So go up, 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 and then you reach to a flat line, and then go down, 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 right? So X is between A and B, going uphill. F prime is greater than 0. As soon as you reach to B, you have a horizontal tangent line. F prime is equals to 0. That means looking at the F prime of X, at X equals to B, there must be a point right there. What about A? It's going uphill. So going uphill means you have to draw something above the x-axis, because above the x-axis, f prime is positive, right? In this piece, f prime is greater than 0. This is f prime less than 0. At the x-axis, f prime is equals to 0. So you have to draw something above the x-axis. So here is how we go uphill. To go uphill, you always need to start with a lot of energy. When you reach to the top of the hill, you can slow down a little bit. So this is how we do that. So we start with something right here. We need a lot of energy, very, very steep, but then eventually the slope is getting closer and closer to 0. So we have that. And then once you pass B, X between B and C, the slope is going downhill. F prime is less than 0. So the slope is going downhill, then we have something below the x-axis. So we start with decreasing. So this is a 0. We start with a little bit decrease, and then eventually we go down fast. So we start with a little bit decreasing, and then eventually, shoo, we go down fast. So that would be the f prime of the semicircle. Let's take a look at the next one. So this one looks like a W. Oh, I haven't sketched the graph yet. Okay, I can do it right now. So the graph looks like this. So it looks like a W, except we have a couple sharp points. So that is the graph of the function. Let's use another color to do the tangent line. Okay, this will be my A, this will be my B, and this will be my C. So at x equals to A, x equals to B, x equals to C, we have a sharp point. So the slope is undefined at those points. But this is a straight line, right? So we have a couple straight line and a couple sharp point. So what is the slope of a straight line? The slope of a straight line is always the same. All right, so here is how I do the analysis. So when x is less than A, what do we have? We have a slope going downhill. All right, that means f prime is less than 0. So this piece is going downhill, is equals to 0. So since this one is a straight line, if you want to make this easier, you can assume the slope is equals to 1 or negative 1. Is equals to negative 1 because it's going downhill, right? And then when x is equals to A, we have a sharp point So the function is not differentiable, so we are going to call this undefined slope. All right, so when x is less than a, the slope is -1. Assuming that this is a -1, we can just assume right now. So we have a horizontal line, right? But at a, this, we have to leave that as an open circle. So the slope is equals to -1 is always -1 because the graph of f is a straight line. What about between a and b? So x between a and b, we have going up, and then the derivative is greater than 0 because the slope is positive. And then this time we assume the slope is equals to 1. So slope is equals to 1, probably right here, right? So between a and b, we have this. Again, look at the graph of f prime. When x is equals to a, we do not have a solid circle because when x is equals to a, the function is not differentiable. Also, at x equals to b, the function is not differentiable, right? Because there is a sharp point. And then from b to c, so x between b and c, what do we have? Looks like we just like less than a, right? So we have going downhill, f prime is less than 0. We can assume that the slope is equals to -1. -1. So that means from b to c, we have this again, slope is equals to -1. X equals to c, same thing, undefined slope, sharp point. And then as we pass c greater than c, what do we have? We have a slope greater than 0 because the line is going uphill. And then once again, you can assume that the slope is equals to 1. So from c to beyond, we have this. So that is the f prime of the given function. Let's take a look at the last graph. So the last graph, oh, I haven't prepared the last graph yet. I can do it right now. So let's pick a color for the last graph. So the last graph, we have this. We have an x-axis, and then we have a y-axis. So that is my y, that is my x. I am going to sketch another one for my f prime. So this will be my x, this will be my f prime of x. This, I don't want to use y, I want to use f of x. So this one, I am going to give you a vertical tangent at this point. Okay, so we have a graph that looks like this, and then we have a vertical line, and then we have this. So it looks like we have a vertical tangent right here when x is equals to a. So what happened when x is less than a? The curve is going what? The curve is going uphill. So we have f prime of x is greater than 0. And then when you reach to a, we have a vertical tangent. But how do we express that on f prime of x? Let's take a look. So we have a slope. Okay, this is going uphill. As we are getting closer and closer to the vertical tangent, do you see that all in sudden, we just have to go up really hard, right? So we are going up, trying to go up, but all in sudden, we have to go up hard. Okay, so how do you express that on the f prime? So on the f prime, we have to go up. So that is for sure. We have to draw something above the x-axis. All right, absolutely above the x-axis. As we are getting as we are getting closer and closer to a, the slope will just go up really fast, something like infinity. So the slope here is how we express that, starting with 0, okay, close to 0, and then eventually we have to go up really fast. So let me try this again. Starting with closer to 0, and then eventually we have to go up fast. So this is my point A. And then what about x equals to a? X equals to a, you have a vertical tangent. So the slope is undefined. What if we pass A? We pass A, we are going uphill still. So the graph is going uphill, so f prime is greater than 0. So here is how we analyze that. We start with something really steep. So we start with something really steep, and then eventually we are getting closer and closer to like a horizontal line, right? So it looks like we start with this, and then eventually we are getting closer and closer to a horizontal line. So we start with something really steep, and then eventually the slope is still positive, but it's getting closer and closer to 0. So that tells me that it looks like at x equals to a, the f prime of x has a vertical asymptote. So that will be the graph of f prime. So as the slope is increasing, it is getting less steeper. So closer to the x-axis is less steeper. Far away from the x-axis, that means you have a big value for f prime of x. Big value of f prime means a big slope. Big value for the slope. Big value for the slope means very, very steep. Alright, so that will be all in this section. I will see you all in the next lesson.